All right, so if I take a look at number 38, 38 said, Marnie pays 6 cents per kilowatt hour. Okay, that's a rate. You guys have to recognize those rates when you see them. All right, so she pays 6 cents per kilowatt hour for electricity. She has a budget of $72 for electricity. What is the greatest number of kilowatt hours she can afford? Okay. Anytime you're writing a game plan, you have to do parts equal to your whole. I would highly recommend that when you're starting a game plan, no matter what kind of game plan it is, no matter what the story problem is, you are simply writing parts equal to your whole. I would highly recommend that. That way you're reminding yourself, oh gosh, that's right, I need to find out what my whole is. I need to figure out what my parts are. Too many people are diving right into, oh, I must have to divide 72 by 0.06 and I'll get my answer. How do you know that? You don't know that. That might be true, but why? All right, so what are we measuring here? Come on, what are the things that we're measuring in this problem? What units are we looking at in this problem? Layla? Kilowatt hours. So I'm dealing with kilowatt hours. What else am I dealing with in this problem other than kilowatt hours? Jack? Money. Yeah, aren't I dealing with money? Okay, I have two different units that I'm dealing with. Chances are this is multiplication and I have a rate in there. How many of you guys see the rate? All right, Emerson, what is it? Yep, that's it. All right, this is money per kilowatt hour. Absolutely, there's our rate. Okay, so now that I've kind of figured out our rate, all right, I need to figure out my whole. Well, my numerator information is the same units as the whole units. So, what information here is my whole? What information here? I'm dealing with money, I'm dealing with kilowatt hours. All right, what information here is my whole? Alex? That's our budget, absolutely. There is our whole. Because we're measuring money. In the end, that's what we're talking about, is how much something costs. I do know that we have a total number of kilowatt hours. That technically is a total. All right, but that's what we're multiplying our rate by. And our numerator information, once I multiply my rate by my kilowatt hours, I'm dealing with money. All right, so I'm going to go ahead and put in here, my budget is my whole. All right, this is that a maximum amount that I can spend or a minimum amount that I can spend? Michaela? That's a max, because I can't go over that. So my parts are my actual total I spent. All right, somebody tell me, how do I figure out how I'm going to come up with how much money I spend on electricity? Kira? Excellent. Number per kilowatt hour, money per kilowatt hour, times my number of kilowatt hours. All right, so that's the same no matter if we have an equation or an inequality. Now, Jack, what's up? I would just write number of kilowatt hours. Yep. Because we're going to deal with that greatest part, that inequality part of it, in our inequality symbol. Okay, so if I have a maximum whole, if my whole is a maximum budget, what does my actual have to be in relation to my maximum? Does it have to be greater than, can it be greater than my maximum, or does it have to be less than my maximum? Romano? It has to be less than. I don't want to go over that budget. Romano, can it be equal to? Yeah. So we can spend all of it. So there is my game plan with my inequality symbol in it. So Mateo, are you cool with that? Okay. So I don't know my kilowatt hours. There is my x. Always define your variable. All right, so I know I have 0.06x is less than or equal to 72. How do I solve this now? How do I solve this now? Michaela? Excellent. So divide both sides by 0.06. My 0.06 is divide out, and I get x is less than or equal to. Well, my coefficient was positive, so I don't need to flip the symbol. So off to the side, you're doing this division. When I do this division, what's the first thing I have to do before I can even start doing any division with numbers? Alex? Yep, move that decimal place. I need to make that 0.06 a whole number. So I move it 2 places to the right, which means I move my dividend 2 places to the right as well. Throw some zeros in there. So now, if I rewrote this, I have 7,200 divided by 6. I don't know if that's easier for you to see. If it is, rewrite it. Well, 6 divides into 7 once. I get 1. Bring down that 2. That's 2. So I end up just throwing those 2 zeros on. So I end up with 1,200 as my number. So x is less than or equal to 1,200. What does that mean? What does that answer mean? Pierre? So Marnie can use 1,200 kilowatt hours. Is that how you want to write it? How do I indicate that it's an inequality? How do I indicate that that the number of kilowatt hours, this says the number of kilowatt hours is less than or equal to 1,200. Maya, how can he write that better? Yeah, she can use 1,200 kilowatt hours at most, or at most 1,200 kilowatt hours. So you do have to indicate in your description, in your sentence, what that answer actually means. It's not exactly 1,200. She can use up to 1,200, at most, a maximum of any of those phrases. Nice job. Frankie. Okay, is there anything on this one? All right, what can I do for you? Yeah, at some point. I've had a ton of tests and other things to do. Grades. So, not right now. Okay, are there any other questions? Okay, put this away, get your notes out. All right, now we're going to look at when we have equations that have division in them. Yes. You do not need a ruler right now. You should have a ruler with your stuff all the time, but you do not need to get it out right now. Yep, so thank you for asking. You do not need to get it out right now. All right, so we are still in 2.10. Come on. Let's cut the chit-chat. All right, so 2.10 continued. So we're going to solve one-step inequalities. With division. All right, so let's review what we did yesterday. Just so everyone is on the same page. I know that there was still some questions yesterday from last night's homework and when to do something, when not to do something. All right, so when we solve inequalities, that have multiplication, the process is exactly the same as equations except. What was our exception? What was our exception yesterday when we were talking about this and in the homework? We solve inequalities exactly the same. We solve inequalities that have multiplication exactly the same as equations except. Aaron? Excellent, perfect. Except when the coefficient is negative, you flip the inequality symbol. Excellent job, Aaron. All right, so what that means is if I have a greater than, it gets switched to a less than. If I have a less than, it gets switched to a greater than. Same thing with the equal to. If I have a greater than or equal to, it gets switched to a less than or equal to. If I have a less than or equal to, it gets switched to a greater than or equal to. All right, and let's talk again about what coefficients are. So if I have 3x, what is the coefficient? Alex? 3. If I have negative 1/2 x, what is my coefficient? Emerson? Excellent, negative 1/2. Now I talked to you guys a little bit about this yesterday, but I want to dive into this a little bit more. I can take this, I'm going to write this as 1/2 x. This is the same thing as x over 2. All right, because this is kind of like, I'm just going to rewrite this. If I'm multiplying 1/2 times x, that's like 1/2 times x over 1. And when I multiply my numerators, 1 times x is x. I multiply my denominators, 2 times 1 is 2. So 1/2 times x is the same thing as x over 2. Are you guys cool with that? Okay, so I'm going to use that right now when we have division, because we're going to see problems that look like this. X over 2 is less than or equal to something. And I'm still going to use that idea of a coefficient. But a coefficient is what we're multiplying our variable by. So I need you to understand, like x over 2 is the same thing as 1/2 times x. You don't have to rewrite it. I just want you to know that. All right, so let's solve some problems that look like that are fractions. All right, so let's just dive right into solving these. So I want you to solve t divided by negative 4 is greater than or equal to 7. All right, so here the variable is being divided by an integer. All right, if that integer is negative, we flip the symbol. Flip the inequality symbol. Alright, so it's the same idea that we did last night and what we were doing yesterday. Alright, because technically this is a negative 1/4 times t. So that idea that if your coefficient is negative, we flip the symbol, that is true here. Alright, but instead of saying it as the coefficient, I'm saying it is if the variable is being divided by a negative number, we flip the symbol. Alright, so somebody tell me, how am I going to solve this inequality? How do I undo that division by negative 4? Romano? to multiply it by positive 4 or negative 4. Remember, you are multiplying by exactly that same number. The biggest mistake that I saw in last night's homework was that you weren't seeing that the coefficient was negative and you were multiplying by a positive ones of those numbers, or dividing. You can't do that. You want to undo that division by negative 4 completely, which means I have to divide by or multiply by exactly that same number. All right, and I do that on both sides. Please show multiplication next to your numbers. Our goal is to get a 1t. If I was to multiply this, if I had t over negative 4 is greater than or equal to 7, and I multiplied both sides by 4, what do I get on this left side? If I multiply both sides by a positive 4, what am I left with on the left side? Here? So my 4's divide out. So what am I left with in the denominator here? Positive 1 or negative 1? Why? I'm dividing out a 4 out of both of these. This is a positive 4. This is a negative 4. So aren't I left with a negative 1 here, you guys? So this ends up being t divided by a negative 1. Is that what I wanted? No, I want that to be a positive 1. Our coefficient. So this needs, when we multiply, we need to multiply by exactly the same number the variable is being divided by. So the negative 4's divide out, and I'm left with a positive. All right, so let's make a note of that. Multiply by exactly the same number the variable is being divided by. If you're taking really good notes and you're writing this stuff down, when you go to do your homework tonight, I do want you reviewing this problem. You don't have to review any other problem other than that. Review this problem before you do your homework tonight. Because I have had a lot of people say to me, I was confused, I didn't know what to do. But then when I pull their notes out, they have everything they need, they just didn't look at it. So before you do your homework tonight, just go back to this problem and reread this page. And be like, oh, okay, so I have to remember that if I'm dividing by a negative number, I've got to flip the symbol. All right, and then, oh, the number that the variable is being divided by, I need to multiply by exactly that same thing. Reread this page, please. All right, so I have t on my left. What is 7 times negative 4? Michaela? Negative 28. Now the question is, what do I do with this inequality symbol? Do I flip it or do I not flip it, and why? Do I flip it or do I not flip it, and why? Aaron? Why? Excellent. I do flip that because I had to multiply by a negative 4 on both sides to get rid of that, to get that variable alone. You guys cool with that? All right, let me give you a couple of them that I want you guys to work on. So I want you to solve. All right, so let's do, first one is going to be 5 is less than r divided by 7. Start on that one and I'll get the second one up for you. All right, so there are the three that I want you guys to do. When you're done done, check with someone sitting by you. See if you guys got the same thing. Yeah. R. So that's 5 is less than R over 7. It looks at square root simplexity. Check with someone sitting by you, see if you guys got the same answer. Help each other out, talk it through. Yeah, turn around. Yes, please. Yes. It does not matter if the variable's first. In algebra, like when you go to get on a test or they'll have it first, but I don't care. All right, who's still working on this? All right, somebody solve that first one for me. Mateo, go ahead. Just tell me what to do. What operation are you talking about there? Excellent. So I'm going to multiply by 7 over 1. How about on the other side? Excellent. Excellent. And then what about my inequality symbol? Does it stay the same or do I flip it? Why? Excellent. Nice job. All right. Dominic, do the second one for me. Excellent. And then what'd you do to the 11? Excellent. Keep going, bud. Yep. Awesome. Sweet. Nice job. Nice job. Yes. It does not matter if the variable comes first or not. Typically, hang on 1 second, please. Typically, when it comes to writing a solution proper order in algebra, they typically will have the variable coming first. I don't care at this point. As long as on that first one, if I were to switch it around, just give me 1 second. If I were to switch it around, make sure that the side of the inequality that stays in the variable can be shared out. It is the side when you switch this one. Right? So this would be R is greater than 35 for that first one. But I don't care. Okay? Yes. Oh gosh. Because I wasn't paying attention. No reason other than that. I made a mistake. Keep the chair down. Yeah. You mean here when you multiply by negative 3 over 1? I'd like for you guys to see it as a fraction so you know you're dividing out common factors between the numerator and the denominator. If you don't write it as it, I'm not going to mark you down. But I want, for your understanding's sake, I want you to understand why you can divide out common factors, because we're multiplying by negative 3 over 1. That's in the numerator, and the negative 3 is in the denominator in the other one. Does that make sense? Yeah, so no, I'm not going to mark you down if you don't, but I need you to know why you're doing it. Okay, who wants to do this last one for me as we finish class? Whose voice have I not heard? Vincent, hop on that one. Not 4 over m, 4 over 1. Yep, leave the m. Okay. Excellent. Excellent. Why am I keeping it? Excellent. How many of you guys are cool with this? Okay, we're good to go. Nice job, you guys.